Okay, so today we're going to talk about the plum pudding model and then other models of the atom. So the plum pudding model was the idea that the atom was a positively charged cloud, and that inside you had your little electrons that were just kind of floating in this little cloud, like that. So that's what people believed. And then around the early 19th century, Mr. Rutherford and his students, they did a little experiment where they fired alpha particles through. And what they were expecting, the alpha particles should just go all the way through, keep going straight. Nothing's really going to happen, because if you shot something like a bullet through a cloud, you'd expect the bullets to go all the way through. But this didn't happen. Okay, so around the early 1900s, Rutherford did this experiment where he fired alpha particles at a thin sheet of gold. So the alpha particles are going through. Here's your little alpha particles. About 1 in 8,000, though, would fire backwards. Now what they'd actually hit, the alpha particles had gone into the gold, most of them, because the atom is mostly empty space, would just pass all the way through. But once in a while, they'd be completely deflected. And this was a total surprise to Rutherford and his team, because they were expecting, because if they thought it was a positively charged cloud, that the alpha particles should always just go through. So what the alpha particles had hit was something incredibly small but incredibly massive, because it must have had a lot of mass to be able to deflect the alpha particles in the other way. So the next slide, I'm going to show you what that model looked like, the solar system model. Okay, so Rutherford then came up with a new model where you've got the nucleus of the atom, and most of the alpha particles, when they're going past, they'll just completely avoid it. If they get a little bit closer, they might have some, because it's positively charged, there might be some deflection, like this, or maybe in the other direction, they might be deflected slightly like that. But once in a while, an alpha particle will come in and be almost completely deflected, like that. And this is what they observed. So they knew the nucleus, it must be basically very, very massive, but incredibly small. And that's how they got this new model of the fact that there's a nucleus inside the very heart of an atom, and 99.9% of an atom is actually empty space. Now, the problem with Rutherford's model is that if you've got a nucleus and your electrons are zipping around like this, what should happen is, if they're moving, they should start irradiating energy, and eventually they'll slow down and they'll crash into the nucleus. And we don't see that happening, so there's a problem with Rutherford's solar system model. And then the solution was the Bohr model. Now in the Bohr model, you've still got the nucleus at the center, but the electrons are only allowed in very defined orbital paths. They're not allowed in between these paths. And when the electrons jump from one path to another, if you give them a bit of energy, they'll absorb a photon of light. So if you've got a photon of light coming in, so here's your wave, the electron can be jumped from one cell to another, or one energy level to another. When it falls back down, the electron will emit light. And this light, the color of the light that it emits, is always the same color. And this is why, if you've got a gas and you take the light from the gas, or you heat the gas and it gives off light, if you look at the light in a spectrograph, you see individual lines of color, and then these correspond to the jumps between the paths, between the orbitals. So if you could jump from this here, or from here to here, like that.